The cost of moving an electrical panel can vary greatly depending on factors such as the size of the panel, the distance it is being moved, and the local electrician's rates. As a general estimate, you can expect to pay around $2,000 to $5,000 to move an electrical panel 10 feet along the same wall. This includes the cost of materials, labor, and permits. When negotiating, firstly consider the safety concerns. A panel located inside a bathroom poses a safety hazard and violates electrical codes. It's in your best interest to have it moved to a compliant location. Secondly, consider the cost of moving the panel versus the bathroom. Moving the panel is likely less expensive than moving the bathroom. Thirdly, consider your leverage. If there are multiple offers, there may be more leverage to negotiate. There are options to explore. Firstly, request the seller to move the panel. This is the most straightforward solution, as the seller is obligated to ensure the property meets safety codes. Secondly, negotiate a credit towards the cost of moving the panel. If the seller is not willing to move the panel, request a credit that can be used to cover the expense. Thirdly, consider walking away from the deal. If the seller is unwilling to address the electrical issue to your satisfaction, consider walking away from the purchase. Based on the information provided, it seems more cost-effective and safer to move the electrical panel to a compliant location outside the bathroom. Before negotiating with the seller, it's recommended to get a quote from a licensed electrician to determine the exact cost of moving the panel. Electrical panels are crucial components of any residential, commercial, or industrial electrical system. They serve as a central distribution point for electricity, receiving power from the utility company and distributing it to various branch circuits within the building. Understanding the function, components, and safety aspects of electrical panels is essential for anyone involved in electrical work or home maintenance. The primary function of an electrical panel is to safely distribute electricity throughout a building. It receives power from the utility company through a main service entrance cable and then divides that power into individual circuits, each protected by a circuit breaker or fuse. This allows for controlled distribution of electricity to different areas or appliances within the building. Electrical panels also provide a means of disconnecting power to specific circuits for maintenance or in case of emergencies. The electrical panel is comprised of several key components, each playing a vital role in its operation. Firstly, the main breaker. This is the primary disconnect for the entire panel and allows you to shut off all power to the building. It is typically located at the top of the panel. Secondly, circuit breakers or fuses. These are overcurrent protection devices that protect individual circuits from overloading. They are designed to trip or blow when the current exceeds a safe level, preventing damage to wiring and equipment. Thirdly, bus bars. These are conductive bars that distribute power from the main breaker to the individual circuit breakers or fuses. They are typically made of copper or aluminum. Fourthly, neutral and ground bars. These bars provide a connection point for the neutral and ground wires, ensuring a safe path for fault currents to return to the source. Fifthly, the enclosure. This is the metal box that houses all the components of the electrical panel, providing protection from physical damage and electrical shock. Electrical panels come in various sizes and configurations depending on the electrical needs of the building. The size of the panel is determined by the total amperage of all the circuits it serves. Residential panels typically range from 100 amps to 200 amps, while commercial and industrial panels can be much larger. Electrical panels can also be configured as either main lug-only or main breaker panels. Main lug-only panels do not have a main breaker and are typically used as sub-panels fed from a main breaker panel. Main breaker panels have a main breaker that serves as the primary disconnect for the entire panel. Proper installation and maintenance of electrical panels are crucial for ensuring safety and reliability. Firstly, installation should always be performed by a qualified electrician who is familiar with local electrical codes. Secondly, wiring connections must be tight and secure to prevent overheating and arcing. Thirdly, circuit breakers or fuses must be properly sized for the circuits they protect. Fourthly, the panel should be kept clean and free of debris. Fifthly, regular inspections should be performed to check for any signs of damage or corrosion. Working with electrical panels can be dangerous, so it is essential to follow safety precautions at all times. Firstly, always turn off the main breaker before working on any electrical circuits. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear safety glasses to protect your eyes from arc flash. Fourthly, never work on electrical panels in wet or damp conditions. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Electrical codes and regulations govern the installation and maintenance of electrical panels. These codes are designed to ensure safety and prevent electrical hazards. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC provides detailed requirements for the installation of electrical panels, including grounding, bonding, overcurrent protection, and wiring methods. Local electrical codes may also have additional requirements that must be followed. It is important to be familiar with the relevant electrical codes before working on any electrical panel. Understanding electrical panel ratings and requirements is critical for safe and effective electrical system design and maintenance. These ratings and requirements ensure that the panel can handle the expected electrical load and protect against overcurrents, short circuits, and other electrical hazards. Firstly, voltage rating. This indicates the maximum voltage that the electrical panel is designed to handle. Common voltage ratings for residential panels are 120/240 volts, while commercial and industrial panels may have voltage ratings of 208/120 volts, 480/277 volts, or higher. Secondly, amperage rating. This specifies the maximum amount of current that the electrical panel can safely handle. The amperage rating is determined by the size of the main breaker or main lugs in the panel. Common amperage ratings for residential panels are 100 amps, 150 amps, and 200 amps. Thirdly, interrupting rating. This is the maximum fault current that the circuit breakers in the panel can safely interrupt. The interrupting rating is typically expressed in thousands of amps, or kA. It is important to select circuit breakers with an interrupting rating that is equal to or greater than the available fault current at the panel. Fourthly, short circuit current rating, or SCCR. This is the ability of an electrical panel or component to withstand the effects of a short circuit. The SCCR is typically expressed in amps or kA. It is important to ensure that all components in the electrical system have an SCCR that is equal to or greater than the available fault current at the point of installation. Fifthly, NEM enclosure type. The National Electrical Manufacturers Association, or NEMA, defines standards for electrical enclosure types. These standards specify the environmental conditions that the enclosure is designed to withstand, such as dust, water, and corrosion. Common NEMA enclosure types for electrical panels include NEMA 1 for indoor use, NEMA 3R for outdoor use with protection against rain and ice, and NEMA 4 or 4X for outdoor use with protection against water and corrosion. Firstly, grounding and bonding requirements. Electrical panels must be properly grounded and bonded to ensure a safe path for fault currents to return to the source. Grounding involves connecting the metal enclosure of the panel to the earth, while bonding involves connecting all metal parts of the electrical system together. The NEC provides detailed requirements for grounding and bonding electrical panels. Secondly, overcurrent protection requirements. Electrical panels must be equipped with overcurrent protection devices such as circuit breakers or fuses to protect against overloads and short circuits. The NEC specifies the types and sizes of overcurrent protection devices that must be used in electrical panels. Thirdly, wiring requirements. The NEC also specifies the types and sizes of wiring that must be used in electrical panels. Wiring must be properly sized to carry the intended current and must be installed in accordance with NEC requirement. Fourthly, working clearances. Sufficient working clearances must be maintained around electrical panels to allow for safe access and maintenance. The NEC specifies the minimum working clearances that must be maintained around electrical panels. Fifthly, labeling requirements. The electrical panels must be properly labeled to identify the circuits they serve. The NEC specifies the information that must be included in the panel labels. Common electrical panel problems can range from minor inconveniences to serious safety hazards. Recognizing these issues and addressing them promptly can prevent further damage and ensure the safety of your electrical system. Firstly, tripped circuit breakers. This is one of the most common electrical panel problems. Circuit breakers are designed to trip when the current in a circuit exceeds a safe level. This can be caused by overloading the circuit, a short circuit, or a ground fault. If a circuit breaker trips frequently, it is important to investigate the cause and correct the problem. Secondly, blown fuses. Fuses are similar to circuit breakers in that they are designed to protect circuits from overcurrents. However, fuses are one-time use devices and must be replaced when they blow. If a fuse blows frequently, it is important to investigate the cause and correct the problem. Thirdly, loose wiring. Loose wiring connections can cause a variety of problems, including overheating, arcing, and electrical shock. It is important to check the wiring connections in the electrical panel periodically and tighten any loose connections. Fourthly, corroded connections. Corrosion can build up on electrical connections over time, reducing their conductivity and causing them to overheat. It is important to clean corroded connections and protect them from further corrosion. Fifthly, water damage. Water can cause serious damage to electrical panels, leading to corrosion, short circuits, and electrical shock. It is important to protect electrical panels from water damage and to have them inspected by a qualified electrician if they have been exposed to water. Firstly, flickering lights. Flickering lights can be caused by a variety of electrical problems, including loose wiring connections, voltage fluctuations, and overloaded circuits. Secondly, burning smells. Burning smells coming from the electrical panel can indicate overheating or arcing. This is a serious safety hazard and should be investigated immediately. Thirdly, warm or hot electrical panel. If the electrical panel feels warm or hot to the touch, it could indicate an overloaded circuit, loose wiring connections, or a faulty circuit breaker. Fourthly, buzzing or humming sounds. Buzzing or humming sounds coming from the electrical panel can indicate loose wiring connections, arcing, or a faulty transformer. Fifthly, dead outlets or switches. Dead outlets or switches can be caused by a tripped circuit breaker, a blown fuse, or a broken wire. Upgrading an electrical panel may be necessary to accommodate increased electrical demand, improve safety, or comply with current electrical codes. Several factors can indicate the need for an electrical panel upgrade. Firstly, outdated panel. If the electrical panel is old or outdated, it may not be able to handle the electrical demands of modern appliances and electronics. Outdated panels may also lack important safety features, such as arc fault circuit interrupters, or size and ground fault circuit interrupters, or GFCIs. Secondly, insufficient capacity. If the electrical panel is not large enough to handle the electrical load of the building, it may be necessary to upgrade to a larger panel. This can be determined by performing a load calculation to determine the total electrical demand of the building. Thirdly, frequent tripping of circuit breakers. If circuit breakers trip frequently, it could indicate that the electrical panel is overloaded or that there are problems with the wiring. Upgrading the electrical panel may be necessary to resolve these issues. Fourthly, installation of new appliances or equipment. If new appliances or equipment are being installed, it may be necessary to upgrade the electrical panel to accommodate the increased electrical demand. This is especially true for high-demand appliances such as air conditioners, electric ranges, and electric vehicle chargers. Fifthly, remodeling or additions. When remodeling or adding to a building, it may be necessary to upgrade the electrical panel to meet the increased electrical demand. The NEC requires that electrical panels be sized to accommodate the total electrical load of the building. Firstly, increased safety. Upgrading an electrical panel can improve the safety of the electrical system by providing better overcurrent protection, arc fault protection, and ground fault protection. Secondly, increased capacity. Upgrading an electrical panel can increase the capacity of the electrical system, allowing for the installation of more appliances and equipment. Thirdly, improved reliability. Upgrading an electrical panel can improve the reliability of the electrical system by replacing outdated or faulty components. Fourthly, compliance with codes. Upgrading an electrical panel can ensure compliance with current electrical codes, which can improve safety and reduce the risk of electrical hazards. Fifthly, increased property value. Upgrading an electrical panel can increase the value of a property by making it more attractive to potential buyers. Several factors affect the cost of replacing an electrical panel. These factors include the size of the panel, the location of the panel, the complexity of the wiring, and the local labor rates. Generally, the cost of replacing an electrical panel can range from a few $100s to several $1,000s. The process of replacing an electrical panel typically involves several steps. Firstly, disconnecting power. The first step is to disconnect power to the electrical panel. This is typically done by turning off the main breaker at the service entrance. Secondly, removing old panel. The next step is to remove the old electrical panel. This involves disconnecting the wiring from the circuit breakers and removing the panel from the wall. Thirdly, installing new panel. The new electrical panel is then installed in the same location as the old panel. This involves mounting the panel to the wall and connecting the wiring to the circuit breakers. Fourthly, connecting wiring. The wiring is then connected to the circuit breakers in the new panel. It is important to ensure that all wiring connections are tight and secure. Fifthly, testing. The final step is to test the new electrical panel to ensure that it is working properly. This involves turning on the main breaker and checking the voltage at each circuit breaker. The electrical panel maintenance and safety tips are essential for ensuring the safe and reliable operation of an electrical system. Regular maintenance can prevent costly repairs and extend the life of the electrical panel. Firstly, visual inspection. Perform regular visual inspections of the electrical panel to check for any signs of damage, corrosion, or loose wiring. Look for signs of overheating, such as discoloration or melting of components. Secondly, cleaning. Keep the electrical panel clean and free of dust, dirt, and debris. Use a vacuum cleaner or a soft brush to remove any buildup of contaminants. Thirdly, tightening connections. Periodically check the wiring connections in the electrical panel and tighten any loose connections. Loose connections can cause overheating and arcing, which can lead to electrical fires. Fourthly, testing circuit breakers. Test the circuit breakers in the electrical panel periodically to ensure that they are functioning properly. Circuit breakers should trip when they are overloaded or when there is a short circuit. Fifthly, labeling circuits. Make sure that all circuits in the electrical panel are properly labeled. This will make it easier to identify and troubleshoot problems in the electrical system. Firstly, safety precautions. Always follow safety precautions when working with electrical panels. Turn off the main breaker before working on any electrical circuits. Use insulated tools and wear safety glasses to protect yourself from electrical shock and arc flash. Secondly, avoid overloading circuits. Avoid overloading circuits by plugging too many appliances or devices into a single circuit. Overloading circuits can cause circuit breakers to trip and can increase the risk of electrical fires. Thirdly, replace damaged components. Replace any damaged components in the electrical panel immediately. Damaged components can pose a safety hazard and can reduce the reliability of the electrical system. Fourthly, keep flammable materials away. Keep flammable materials away from the electrical panel. Electrical panels can generate heat, which can ignite flammable materials. Fifthly, hire a qualified electrician. If you are not comfortable working with electrical panels, hire a qualified electrician to perform maintenance and repairs. Electrical work can be dangerous, so it is important to have it done by a professional. There are a number of common misconceptions about electrical panels that can lead to unsafe practices and costly mistakes. It is important to understand the facts about electrical panels to ensure the safety and reliability of your electrical system. Firstly, misconception: all electrical panels are the same. Fact electrical panels come in different sizes and configurations depending on the electrical needs of the building. It is important to select an electrical panel that is properly sized for the electrical load of the building. Secondly, misconception: circuit breakers never need to be replaced. Fact: circuit breakers can wear out over time and may need to be replaced. Circuit breakers should be tested periodically to ensure that they are functioning properly. Thirdly, misconception: it is okay to overload circuits as long as the circuit breaker doesn't trip. Fact: overloading circuits can cause overheating and can increase the risk of electrical fires, even if the circuit breaker doesn't trip. Fourthly, misconception: it is safe to work on electrical panels with the power on. Fact: it is never safe to work on electrical panels with the power on. Always turn off the main breaker before working on any electrical circuits. Fifthly, misconception: only a qualified electrician can work on electrical panels. Fact: while it is always best to hire a qualified electrician to perform electrical work, some minor maintenance tasks, such as replacing a circuit breaker, can be performed by homeowners if they follow safety precautions. Firstly, misconception: aluminum wiring is always dangerous. Fact: aluminum wiring can be safe if it is properly installed and maintained. However, older aluminum wiring can be prone to corrosion and loose connections, which can increase the risk of electrical fires. Secondly, misconception: ground fault circuit interrupters, or GFCIs, are only needed in bathrooms and kitchens. Fact: GFCIs are required in any location where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Thirdly, misconception: arc fault circuit interrupters, or FSIs, are not necessary. Fact: FSIs are designed to protect against arc faults, which are a common cause of electrical fires. FSIs are required in many locations by the NEC. Fourthly, misconception: electrical panels don't need to be inspected. Fact: electrical panels should be inspected periodically to check for any signs of damage, corrosion, or loose wiring. Regular inspections can help prevent costly repairs and extend the life of the electrical panel. Fifthly, misconception: all electrical work requires a permit. Fact: some minor electrical work, such as replacing a light fixture, may not require a permit. However, most major electrical work, such as installing a new electrical panel, requires a permit.